Right, so I'm going to just give you an example of how you use Circuit Wizard and a Genie project board. First of all, I'm going to just do a really basic traffic light. Now you could copy exactly what I do here and get a minimum mark, but probably a pass if you just do it like this. But you might want to look at part 2, look at slightly more advanced programming. So for example, if you're going to do a flashing amber light, rather than just saying on, off in the flowchart, you might want to say on and off and repeat 5 times. Or you might want to wait for the traffic to flow for 30 seconds before the amber light comes back on to allow traffic to flow through, like real pedestrian crossings do. That kind of condition. You can look at it all in the second part of this video, so the next video. Anyway, we've got 2 areas that we might program with: circuit design and product design. Now product design is just a little bit more colorful and gives you, doesn't give you schematics, but it gives you pictures of the stuff. It's not very good if you want to do slightly more advanced outputs, if you want to kind of add transistors and more exotic components, then use circuit design with the schematic things. However, this one will give you a ready-made project board, so you get them here. Now we're using the Genie 18, so we're going to go just drag it over to your thing here. Now, just so you know, you'll want to have a battery on it in order to simulate it for it to work, but you can go straight into the flowchart and just start doing it in real life. So once you've made a flowchart, you can upload it. But for the record, we'll just show you how to do that, so you can watch it virtually here and check it works before you upload it. So power supply, 3AA battery clip. And I'm going to just drag this onto the 0 volts, so that's the black one, and then the red one onto the plus volts. Okay, we'll want a switch. Remember in the first or the second video we were talking about momentary and latching. We're just going to have a push to make switch, and this will go onto digital input 0. Doesn't matter which way around the wires go, and you can see they're blue for both, so that's fine. Now, because this has got built-in pull-up resistors, or pull-down, I can't think, you don't need to add extra resistors to protect it. You don't, on the simulation, need to add resistors on the output as well for it to be fine. But in real life, you should do, just to protect your LED. Again, in part 3, I think, of the video, I explain about protecting LEDs with resistors. So when you use an LED, any of these ones, just beware. These side views are easy to identify: long legs positive, short legs negative, and there's a notch, so that's a smaller bit there. Whereas these ones, not so easy. All you need to do is just move it, and you can see there's that flat side there, which means negative. Okay, so when you're looking here, all of these are positive, and all of these are negative. So the flat side on the red, I'm going to go Q0. Okay. And then the not flat side goes to positive. Now remember also, I want to put an a resistor in sequence. Now this is where this is a bit of a kind of silly mode, because it's not so easy to put things in series, and you can't even find, I think there might be resistors here, but yeah, I recommend if you're designing your own specific circuit, which is most cases, use the circuit design rather than product design. So yeah, red on output 0, amber on output 1. Remember the flat side on the right, when you drag it you can see it. So flat side to Q1, and then the common one is positive. Now that to me is a bit unintuitive. You would have thought the positive gets spat out of the program and it puts on an on. It's often called in logic 1 is on, and you think on is going to be volts, but actually what's happening here is it's draining. So this is the high, and it's opening, almost it's like kind of flushing through into 0 volts here. So it's opening this gate, the transistor, and it's flowing down. Slightly more advanced than A-level design engineering, learning about that. In electronics you might need to kind of understand a bit more. Now I've not made this very intuitive because I've gone 1, 2, 3. So that's positive on there, but the red, yellow and green is the wrong way around. So yeah, that should be there. And that should be there. Now I've demonstrated beautifully how this tangle of kind of visual wires is a nightmare sometimes for tracing which one's which. I probably need to check later on if this doesn't work, that I wired them up right. Anyway, so that's all you need to make it work. Remember, in real life, put some 300 ohm resistors in series of these to protect the LED. So in the flowchart, all we need to do is we're going to start off by asking a question. Has the button been pressed? Now these diamonds generally in flowcharts mean decision. So a diamond means make your mind up. Now because we've loaded in a Genie 18 when we dragged it in, it gets the right inputs and outputs straight away. If you don't load in the correct project board, you might not have the correct inputs and outputs loaded up. We're using just digital naught, so I'm going to ask, click it twice, and the question is this one on? That's all it says, and it'll kind of put that in the actual thing so you can reference each flowchart. Sometimes, like now, for example, if I'm going to put remembering, got already, but red was 0, so I'm going to say green. Let's just have green on. Okay. So you need to say the other ones are off because otherwise it will leave them on. If the last command said put the green one on and then you have this command and you don't put anything on the other ones like this, nothing will change. So if it's already on, it will stay on. In this case, we want to say no, those two are off. Okay. So Q2, which is green, I hope. Now this time I'm going to write a caption and I'm going to just put green on. And it just makes life easier when you come to having a slightly more complicated flowchart or someone else is looking at it. I can just see that's green on. Let's have all the states. So let's have amber on. So we'll just have amber. And we'll change that one to there and that one off. Oop. And then red on. It's that one. Okay. Simple so far. So these little rectangle parallelogram things are just telling us what the outputs are to be. Now, think about it. You've got a traffic light. Let's say you walk up to the traffic light. We're only looking at the actual motor traffic, not the pelican crossing, not the red or the green man here. So normally, by default, the green light is showing. So I'm going to have that before the question. So that means when you start the program, you should just have the green light on. Neither of the other two, because they're saying make sure they're off. Now, when the question is the button pressed, and you drag out the first line, it defaults to yes. So in other words, the first thing you drag out of this question is normally the yes, if this condition is met. And then if it's not met, we're going to kind of carry on round in a loop. Now we could carry on round in a loop here, or we could say, make sure the green light's on. Is it pressed? No. Make sure the green light's on, etc., etc. It's not necessary to keep making sure that's on because it won't have changed before there. But you can see where the flowchart command, where the arrows are important, where it goes. Now, once the button is pressed, and if you by accident drag out the no command first, it will default to yes, then you can just right click and swap yes and no like that. But in this case, this is correct. So, now what happens here? Well, as soon as you press the button, the amber light comes on. So I'm going to just move that out of the way. And then I'm going to do red on, and then amber, and then it goes back to here and it stays green. It's a really basic traffic light, this, obviously, like those of you probably noticed they're slightly more complicated, where you might have a flashing amber light or a red and an amber light, depending on the thing. Anyway, this is really basic. So we can leave that off to the side or delete it and just copy it here. Now let's just see what happens back on this design thing, which is where it's useful. You can test it before uploading it. You press play up here, you can see what happens. Now we've got the green light on, as we expect. Let's just zoom out and then press this button. Now what happened there is it happened instantaneously. So you didn't even get a chance to see the amber light. Yeah, I saw it just then. That's because we haven't told it to wait. It's an immediate command. And as soon as that command's met in split second timing, you won't even notice that amber light coming on. So you want to tell how long it's on for. Now, there's two ways of doing it. You can either, those of you eagle-eyed might have noticed here, we've got a wait command. And we can say a second. When you're doing a test program, be it traffic lights or anything like that, and you've got long wait commands, then don't bother doing a full 30 seconds or whatever, because it's boring waiting for it to happen. Just simulate it with a smaller amount. So you can either do it like this, or there are wait commands down here. Now there's two types actually. You've got wait, which is in seconds, and then pause, which is in milliseconds. So if you want a really quick thing happen, you can do it on pause. So just have this on wait, like that, and then let's go back to the design and test that. So green light on, press that, amber 1 second, red 1 second, amber, and then green. Okay, so that will get you a minimum mark, but a pass mark if you can demonstrate that. However, you probably want to do something slightly more advanced, and we're going to look at that in part 2 of this video. So we're going to just test this now. I recommend watching the second part of this video anyway, because it will give you not only the tools needed for kind of an A grade on doing the traffic lights and the random dice and the game, but you might find some useful commands. We're just going to cover the kind of basic useful commands for doing other stuff as well. So now I'm going to make this circuit in real life. Now we're going to plug LEDs into these outputs here. Because, remembering in the second video, we need to protect the LEDs with resistors to stop too much current going through them. We want to have something in series. Now it's not going to be so easy to plug an LED in series with a resistor and then back into another line like that. So we use what's called a breadboard here. In true Blue Peter fashion, here's one I made earlier. Now I'll plug this up and I'll show you how it works. So if you remember all of these lines here, when we made this board, remember on the back all of these plus volt lines are connected together, which means they're common, they're all shared together. So we can actually just transpose that. If I just plug the first one onto this rail here on the breadboard, if you notice we've got a plus line all the way along that line, that means they're all connected electrically. Similarly, this blue minus volt line, 0 volts, is all connected together as well. Now we're not actually going to use the minus volts, we're only going to use the plus volts. So it means anything on that line is connected. Now unlike these rails here, these rails are all columns, so all of these columns are connected. So it means each of these outputs, so for example the red LED, if you remember you've got to get an LED the right way round. There's a long leg with plus and a minus with a short leg. So the long leg will go into the plus rail, and then the short leg will go into a column here. Now in that same column is that resistor, that 330 ohm resistor. That is straddling across to the next column. Now these columns are independent from one another, so that one isn't connected to that one, which means we've now got a connection to there, join there, and a connection to there. And all I need to do is finish that off with another wire, which I'll put in like that, to Q0, like so. Now I'm going to do that to the amber and the green. They're in the same way, so the long leg into the plus. They're all sharing the same thing. So we actually only really need 4 wires as opposed to 6 for these 3 components. Okay, so that's the outputs all done. Now we've got this little micro switch. Now if you notice, if you can just about see on the camera, we've got 2 straight legs like that, end on. So the narrow end, you see the 2 straight legs coming straight down like that. If you look at it from the side, they're slightly more arched, like, if I can show you, like that. It's the straight legs, the narrow 2 like that. they're the two that make an electrical connection when you push it. So they're not connected together, but when you push it, they are. So it's just an important way of remembering it. But remember, if you can't figure out which way round they go, just use a continuity tester on the voltmeter. Remember that, if we can get it in view. Oops, that one there. So that way you can just tell by touching the two legs if they make a beep or not, if they're joined. So we're going to put that one there, straddle across these two columns. Now if you can just about see that, the two narrow legs straight down into separate columns like that. Now these plus volts here are the same as these plus volts here, so I can just use that same rail across like this. Now I've run out of colour coding, but if you're going to do a complicated circuit, I do recommend putting black wires in for minus volts and red wires for plus volts. Just makes things easier to recognise what's going on. Here that's going to go into the plus volts, so it's totally not colour coordinated. And then the white one we'll put in the other column there, and that will go into AD0. And there you have it. Right, so with it over by the computer, you want to make sure you've got a long enough cable to be able to reach it. This headphone style jack will go into this socket like that, and then the battery snap onto the battery pack like that. Now if you've got Circuit Wizard already open, you should have a flashing light like that. That means it's all happy. On Circuit Wizard as well, you'll see USB down here, and it says a Genie 18 microcontroller has been connected. Now if for any reason you haven't got any of that, it might be worth just doing a little bit fault finding. Just try someone else's Genie, try someone else's battery pack, try a different computer, see which is causing the fault, and you can narrow down. It might be an IT issue if the USB thing isn't installed on the particular computer you're using, for example. But the important thing to do is to see that you've got a flashing light on here, got USB here, and a Genie 18 is connected. And it's as simple as that when it works. And even simpler still is uploading it. All you need to do is click Run Live here. So I press that, it says running live, and hey presto, there's our green light. So let's see if that works. Remember, I've got to wait 5 seconds. Amber, red, amber flashing, and back to green. If I press it too soon, nothing happens because of that timer. So give it a bit longer. Yeah, that seems to work fine. Now another useful thing to do as well, if you notice below Run Live we've got Debug Live. If you click on that and then press Start, it'll actually do the flowchart as well as doing the output. So you can see where, if you've got some problem with your circuit, you might be able to spot where it might be going wrong. The only trouble is with this, it happens a lot slower than in real life, so that can be a problem if you're doing something that needs a bit of fast timing, or say something like a rotary encoder, which we'll be covering in the next couple of episodes. You might find quite difficult to check out. But anyway, you've still got the ability to use the inputs, and you can see them here as well. If you click View the Digital Inputs and Outputs, when I press the button, it comes out as 0 like that. I might have to hold down the button just so that it can go through the flowchart, and you can see at each point it's doing exactly what the flowchart is doing on the hardware like that. So that's quite a useful little feature to be in, to be able to check things out. If you don't want to be in that, close that and cancel that. Now, once you've run live like that, it will be uploaded and stored on the memory of the PIC, which means you can unplug that and it will stay connected, it will stay working. So you've still got a traffic light wherever you are, which is the great thing about a PIC.